In this class, my schedule is like this. First, I am going to Professor Narajan. Unfortunately, he is not well, therefore he is not able to come. Between us, what we decided was we will spend some time on this group project, so that he is also brought up to date. But I will break him separately. So the first part I am going to talk about group. There is some little bit of uncertainties there. This will resolve maybe 3-4 minutes on the group. Then at the end of it, I am going to put a deadline that time the group has to tell me what is the topic. So that is it. Then I will continue with the past, concluding part of the sample example of this water business, where I will bring it to a conclusion for that. So that is what is the broad plan from there. From the data that all of you had given at different points of time, I have made this groups. So here it is the display. Just look out for your roll number if it is there. This is called group 1, just group 1 for some reason. There are 5 people in this. Check whether you are figuring somewhere else or not, right? If you have if your name doesn't figure in any one of them, let me know. So this is group 1. Group 2 is a slightly larger group. That is because there were some changes made at different points of time. Maybe this is of interest to you. So 7 is not a problem if you want to retain there, but if you want to switch anything, just let me know. Because I think a couple of people were not present. I think your name was removed. So I said that cannot be possible. People must be present and agree to changes. So shall we leave it, or if you want to change, you have to write email to me to which group you want to go. Only when the student says I want to be in that group, I will take it, because that's only fair. So this is group 2 as of now. This is group 3. Okay. 4. 5. So total of about 10, 20, 29 people are covered. I hope everybody is covered somewhere or other. So this is the group. This is already in Moodle, and in the group we have to decide that there will be a common submission for all of you, and then the grading will also be common or individual, that you have to come back and tell me. As of now, I am taking it as common. Okay, so that's on the out of the group business. So I will pick up from here. Just to recall, idea was you take a topic, you study the existing technologies, methodologies in some detail. When I say by in detail means at least you should go through the complete flow diagram of that in some depth. Why the flow diagram is like that? That is very important. Then secondly, you have to understand what is the kind of equipment broadly involved in this. You should get a feel of this. So if we know these two for any process, then you will be able to come out with something called what is the performance standards of that process at that point of time. It will vary from process to process. In the case of the water example, I took these are the performance indicators, which means how much is the investment per output and what is the operating cost per unit of output. These are the two parameters, and typically in what sizes plants have been built. This is also key for scale up. So this is the number that we have got from here. We discussed very elaborately in the last class this 1 crore, 9 crore. You must get a feel of this. It's not numbers that you have to memorize and keep it in mind, right? That's okay, how many numbers can you memorize? It's pointless. But if you have gone through the flow diagram, you will get to know why is it likely to be around 1 crore, why is it likely to be around 9 crores for that. And I think I spent some time actually in the class going through this flow diagram and return. So this is for your projects, you have to similarly keep that in mind. Similarly, the operating also, why is it like this, why is it like that, you will get some idea. From there, now the last part of that is, now we have studied a process in depth, we have understood some performance metrics. Then the next step is to identify, are there any more open opportunities for improvement. So you can take advantage of that. The take advantage can be in 2-3 ways. If you are a running manufacturing kind of a job, company, then you will know what can you do with whatever you already have got. Let's say in this hypothetical example, you are one of the water treatment plant operators. either a seawater based RO plant or a regular water treatment plant operators, you will get some feel of what is the investment you have already made, what is the operating cost you have got. Then your focus will be how can I bring down the operating cost, right? Because you already got the plant going through that. So that kind of a thing will focus. You will look for where are those opportunities there. If you are on a different job, which is like building plants, water treatment plants, you build and sell to final customers, then you look for what can I do, and there your focus will be on 1 crore, 9 crore, whereas the previous example will be 11 rupees per cubic meter and 85 rupees per cubic meter. So that is how it is. And if you are a technology development company, you look at how, what can I do to bring down both of them, or look for a need which is not being met by this existing WTP fellows as well as the seawater reserve. So this is the link comes. That is what I am going to pick up on this. We said that usually source of water, if there is a river or a lake by, you go for a conventional water treatment plant, works cheapest, best option for everybody. But very large cities where there is no river water nearby, but if the city is close to the sea, then seawater RO plant is unbeatable. Really, it works out that way. But what about locations? Now we have studied both. You are now thinking, is this all in the market, or is there anything else, newer scope of technology where there is no open area? For example, if there is a location which is not close to the sea, it is also not close to the river or a lake, and of course it is growing, let's say for some reason that place is growing, population is increasing, what do you meet the water requirement for that? There are several ways. You can think, okay, if you don't have a river, if you have a surface water, if you don't have a sea, I'm sure groundwater must be there somewhere else. There is some aquifer. So people will look for an aquifer, put a large big boreholes, take out that water, and depending on the quality of the water, either you will go for a conventional water treatment plant or you will go for a brackish water, because it will not be like seawater bad quality. It will be somewhat salty perhaps. You can still go for a reasonably sized brackish water RO plant. So that is one option. But that's not the only option. The other option I am going to think, and this has been actually implemented, is you should also look for, not every place you have to have close by. I have been using this. What is close by? Is 5 kilometers close by? 50 kilometers close by? So there is some judgment that we have to make. The judgment is, if it is 500 kilometers, still you can pipe water, but it will be slightly more expensive, because 500 kilometers you have to transport that water. It's not impossible. In fact, the HPJ gas pipeline, which is India has set it up in the 1970s and 80s, it is running to 1,800 kilometers across India. Petroleum products, IOCL, BPCL, they distribute by pipelines. So it is not impossible. And United States of all countries, if you take, there is a country is crisscrossed with pipelines for carrying crude, gas, everything. So laying pipelines across very long distances is not a technologically impossible situation. It is also commercially a viable solution. It is not that as if it is very expensive. You cannot pay for it. But if you can keep the distances smaller, obviously the advantages are better. So one of the possibilities could be, if the sea location is not very close to the river or sea, find a location, set up the plant. If it is near the sea, seawater RO plant. If it is near a big river, set up a water treatment plant and pump the water back to wherever required. So this option is there. Technologically, it may not sound very sophisticated. And what is technologically sophisticated? But it works reliably, proven, low cost. That is one. Second is, this is an interesting option. This will bring the question, which means practically we will say that more or less you have to set up seawater. How many, can you just keep on increasing the number of seawater desalination plants? There is a limit, right? You take India map, for example, Indore, Nagpur, Chandigarh, Jaipur. These places, if they tomorrow want to have water, we are back in this logic. We will say we will find some seawater closest radius to east coast or west coast, put up a seawater treatment plant and pump it there. So you might wonder, it's okay, but is it really? I mean, going forward 40 years, 50 years from now, is this the only way? there is another way. This is where the technology part comes into the picture. For which we will go back to our fundamentals, which is we started in the first 3-4 classes back. We have to estimate what is the water quantity for people consumption. We started from some, right? I gave a number of 150 liters per day. Broad guideline. It can be more, plus or minus a little bit. But for example, take it as 150. Good number. What happens to those 150 liters? So let's say it is available in a household. Per person 150. So 6 people are there in the house. So 1000 cubic meters roughly. What happens to the 1000 cubic meters is, if you really look at this, you don't really, obviously mass balances, nothing can be destroyed. So if you trace it down, quite a lot of it will become wastewater. Take our typical house for example. From morning when you wake up, brush the teeth, wastewater. Take bath, wastewater. Wash the clothes, wastewater. Go for cooking, wash stuff, wastewater. Then put water into that whatever food you are making it. It gets steamed, hydrolyzes, all those proteins and carbohydrates are getting hydrated. Maybe it is conserved. After some time we eat it. Some of it is wastewater. So almost you will find very large percentage of the consumption, so-called consumption, actually turns out in the same doorsteps as wastewater. This is a very important point, obvious point, but sometimes when you look at it, it will throw up some ideas there. In fact, human beings are water generators, because if I take food and carbohydrate for instance, as an example, you can use it for fat, you can use it for proteins, everything, carbohydrate. General formula is CH2ON, carbon, water, n number of times. Eat it, then take a breath, this oxygen goes inside, joins with carbon, makes CO2, come out. What happened to the water inside? It remains. Some of it, when you breathe out, because it is slightly moist, you can see what we breathe. So a little bit of water has gone into the atmosphere, but quite a lot of it remains in our body also. If you take fat for instance, which is CNHM, C will become CO2, that H actually gets transformed with oxygen into H2O. Actually you generated water. So it is nothing like there is consumption anywhere. Quite a lot. In one line answer, if you really deep is, there is almost a lot of water is available in the same place as wastewater. Of course, it is mixed up with sewage, all sorts of. Now, in large places, we are talking about big populations. We are not talking about one person solution, one family solutions. We are talking about society solutions. So, almost all decent cities have these days wastewater collection systems established. It's a very, in fact, the civil engineers' biggest contribution, in my opinion, was discovering that you can have underground sewage pipeline and collect it and use them. There's a very nice story about how London at one point of time was reeking and smelly and dirty, and people had all sorts of diseases onto that. One civil engineer got into the picture and said, I am now going to clean it up by laying pipelines from individual households. Today we take it for granted, you flush, it goes. That system he thought through, collected, sized it, depth, went to a central point, take it to another places, treat it, and the treated water was put into river Thames. So here almost in all cities there are sewage treatment plants. Whatever sewage waste we collected, whether it is wash water or it is for clothes, everything is collected to a common place, it goes, and these are distributed inside the city. Chennai city, for example, has about 12 or 13 sewage treatment plants at various places. And then you treat them out to bring down the COD, BOD, biological content, everything there. And the treated water, what happens to that? And this treatment process, out of the sewage water, something like 75-80% of the water you can get it back. Because only the organic matter and the biological matter gets into a sludge. Rest of the water remains as water. So quite a lot of water is collected. Now, till about 10 years back, what was happening is, after you ensure that the treatment quality is meeting the standards of sewage treated water, it will be just dumped into some nearby open drain. It will just find its way to nearby river, water, lake, whatever, it will just land up there. So that is what is happening there. This is brings a picture that means all the big towns and cities, and after a point of time even smaller towns, because in smaller towns, our government recently started about this creating toilets, right? This is not always the case every place. People used to have some individual arrangements and so on like that. Now there is a real push on the part of the government. Cities 100%, big cities, metropolitan cities, cities with 3 lakh, 2 lakh, 75,000 is in the process. Idea is really go down to even 10,000 population group and set up collecting sewage water for treatment. This is going on. So you will have lot of water, treated water at some places. Can we do something about that? There is a special type of a treatment process that has been discovered, which is after the sewage is treated, normally like I said, it is treated for what purposes? To remove all the organic matter and all the substances. They are brought down to, for if you are wanting to just discharge it outside to safe liberties, something is there. You can read up. It's about 30 BOD content is 30. If you bring it down, then you can discharge. You can treat it further by a membrane based activated sludge process of bringing it down to 2 to 3 ppm. It's just a question of designing it. So after you design and bring down the COD and BOD to that level, you can take it to a further RO plant. Now this RO plant is beautiful because it is not having to deal with seawater of 35 to 40,000 ppm solids. So its osmotic pressure is very low. This gives a clue that the RO energy consumption from that plant will be very low compared to seawater. You have already treated the organics. So the tendency for fouling of the membranes also will be very, very low. You can get very large recovery. Seawater, I said, it's only about 45% of the water, half of the water comes, because if you start with 38,000 ppm of solids, as you concentrate, beyond the point, salt will start coming out. It will reach the solubility limit. So all the membranes will get blocked at beyond that recovery. This is what water we went in initially, drinking water, right? Mostly potable water, 300, 250, 300, 400 ppm. So this water can have extremely high recoveries. So you have got very high recovery, you can purify to the same level, and it can be at the end of this process drinking water quality. In fact, the one thing which I made, Singapore is a great place, right? It's a small, one city, one nation, and they are sort of globally very well integrated. And in the last 60, 70 years, from a third world country, they became first world country. It's a remarkable journey. Some of you might have gone to Singapore and see. Read up about Singapore's development. It's an inspiring story, how it was. And I have been very closely watching Singapore's development for at least last 40 years. Amazing how they transform. Some of you who go around in Chennai, this Coombe River on and off goes, right? This Coombe River, what exists today, if you imagine 10 times worse. That was the condition of Singapore River when Singapore became independent around 50s. Same period is like us. And today you go and see that place. So Singapore is very creative. So what they have done, and they are also short of water. It's a city, one nation. So where is the lake? Where is the river? So they said that they have large seawater desalination plants, several of them across the island. But they said this logic, whatever water we have once made and given to the people, let it not go back to the sea. Catch it, treat it again. This water was called new water. It is sewage treated drinking water. And sometimes there is a stigma, right? Sewage water drinking. So the Prime Minister of the country, when the plant was started up, to give to the confidence to people, he went and they took a video of him going through. Here is the sludge which is coming, and then at the end of it, this water is going. He took it in a tap and drank. And then he said, this is the quality that you can drink, but we are not asking you to do that. Because still people everywhere they have some reservation, right? You walk into the plant, this side sewage is coming, drinking water is coming out, how many people will be happy? So what they have done is, they now have some rainwater catchment places here and there. Okay. So this treated water goes to those catchment areas. If you really look at what is our lakes, this lake is not pure water from the sky is collected. Anybody who has gone to the lakes would have seen, not perhaps in the city they wash automobiles, probably something. But if you go to town places, buffaloes, all sorts of things are happening inside the same lake. Only you don't look at that side and you take water from this side and people are going. So people are used to lakes. So this treated water, which is actually much drinking water quality, is put back into the lakes. From the lake the water is taken again for a water treatment plant. So it's kind of, then it satisfies people, okay. This is a lake and I am not taking lake water and drinking it as it is, right? Anyway, lake water is going to a water treatment plant. We saw that process, flocculation, sludge removal, activated carbon treatment, chlorination, drinking water requirement, comes back as drinking water. If you do that, then what has happened is your consumption, 150 liters per day, actually turns out to be probably 15 liters per day per person. Net, account for the loss. With that logic, you can have even those places who don't have, very close by sea, you can have a large seawater desalination plant and take care of that, provided those cities internally, they cannot say, I don't even have sewage. This won't work, right? You may not have a river nearby, you may not have a sea nearby, but if you got water, piped water, you can't say, I don't have sewage nearby. In every house you are generating sewage. All that requires is, I am very happy our Indian government is actually taking this, creating sewage treatment plant in all metropolitan cities. They are more or less finished. And in towns, which means lot elaborate pipeline digging, like metro, you dig and then you have to go through that inconvenience. But if you lay those underground pipelines and sewage treatment plants, you have source of water. Can we agree on that? Here therefore the third technology is like to supplement the regular water treatment plant and the seawater treatment plant, you can have tertiary treated plant with an RO which will sort of recycle the water back. With that, for a long time to come, the increasing population, wherever they are located, you should be able to meet it between that 11 rupees per 1000 liters to 85 rupees per 1000 liters. This, by the way, this tertiary treatment plant, now I am going to ask you, let us guess. I have not given you the flow diagram, right? You can write, there are flow diagrams are available in the net, you can go through. But now picturize the flow. What is it likely to be? There is a sewage treatment plant already is built. So it is treated it to some level. Like I said, up to 30 ppm BOD it is already treated. That water is coming. You set it up, this final tertiary treatment plant, next to that. Clear? And the water, inlet water will be as good as drinking water, because it is drinking water which came contaminated. We have removed all the contaminants. Now it is like 300, 400 only will be there. I have taken that sometimes, it comes, rainwater also goes and falls, some rubbish falls into that. So 500, 600 ppm is a reasonable assumption. For getting good water from this low TDS, you get very high recoveries. That's the point I mean. So therefore, go back to your investment cost per MLD. Will it be like seawater treatment plant? 9 crores? Like unlikely, right? Because I said 9 crore comes because 45% recovery, everywhere is salt, superior material of construction, all sorts of. Here it is not, it is just water. So it will not probably be as small as 1 crore, because that is clean river water just. So it will be sort of very close. So it's more like, actually it is found about 2 crore per MLD will be the cost of this plant. So you've got a third option, water treatment plant, capital cost per output, operating cost. Come to operating cost, the pressure required for RO to work will be much lower. Why? because this input water is not having high TDS. It is only 700, 600 ppm. That point is clear. Therefore, you will get a third option which is in between the two, but more towards regular water treatment. So that is the option that can be used. So this concludes our analysis of affordable water for large population. Quickly, what we have done is we have took and studied what is existing widely practiced. It's a very good indication. Human beings are generally very intelligent everywhere. So if anything which is large volume, there is some merit in it. We can't dismiss it. So water treatment, simply we went and studied what is the way things are being done. We went through the flow diagram so that it into the brain performance metrics, that's how it is working like that we got. Then we looked at, is there any open gap that we can exploit where there is need cannot be fully met. I gave this example of totally inland one. It turned out that you go back and say we are looking for source of water, what about the sewage that we produce and technology. So that is what it is the conclusion of this. Of course, sometimes what happens, like Chennai city has already implemented it. We should be very happy with that. I am very happy with that. The last company I worked, we set it up actually. So I had a lot of satisfaction of seeing this happening. Still here the level of acceptance has not reached the level of even wanting to put it into a lake and then take it back through a water treatment plant. So instead what the government has done, they have offered this water to industries. Two purposes. One is of course people's acceptance over a period of time. That is one reason. Secondly, water is for people, it is practically zero cost. I told you, it might cost so much, whatever you have shown, but who pays for water? It's just you expect some very trivial amount of 500 rupees per year you pay for water. So they also have to sustain, they have to set up new plants for meeting the requirements, they have to meet the electricity requirement. So what they found is, pass it on to industrial consumers. Industrial consumers where they will go for water. Same problem for them also. If you are close by a river or a sea, you can do this. But if you are slightly inland, you are stuck. So this water is sold at 100 rupees per cubic meter. Cost of making it is, in this case, it is sewage treated water. So it is not 85 rupees per 1000 liters. It will be between 12 to 15, 20, 25. So you have a cost of 20, 25 rupees per cubic meter. Industrial consumers are willing to pay 100 rupees because they can't otherwise get water. So government also makes some good amount of revenue and uses that money to set up water treatment plants for people. So it's a very nice arrangement of whatever model you call it, development model. Give it to somebody. Okay, so that is what is the part. Now, this thought I will just mention, but optionally I will go through. Sometimes in the last class especially I said there are lots of things you hear about. One of the things you would have noticed in my class, my approach has been, I take a lot of let's say wicked pleasure in taking a dig at this hype. In somebody hypes it up, I have a lot of fun going and poking that balloon. It's nice because intellectually it keeps you stimulated. You get to know what's happening. Plus you also have to be sharp because in that case that fellow will poke you back. So you should be on your toes. So I get a lot of joy in doing it. I mentioned a couple of efforts are going through. If you go through, I wouldn't name, but if you see the words like thermal desalination plants for meeting rural areas is a big topic. So we assume those guys, our brethren who are in the countryside, they are all to be treated differently than us. We can have seawater RO plant, but they have to be fed by thermal desalination plant. So lots of work has happened trying to develop a technology. So that is available. I just mentioned about it. It's all there in the Moodle post. At your own convenience and read through that, make up your own mind on that. I brought analysis, but I said let me not overdo it, so I will leave it. The other thing that has come out also is Vayu Jal. I mentioned Vayu Jal, right? Here is another hype that comes. There is no, you don't worry. There is no sea nearby, don't worry about that. There is no river nearby, don't worry about that. Air is there everywhere, we will get water from air. This is Vayuja. And actually, yes. In fact, there was a demo unit which is available in ICSR also. Some of you can walk across. And a bigger unit, if you guys ever have a habit of going into a place called temple, there is in Mylapore temple, there is something which is installed there. The principle is very clear. This I will take a few minutes. Thermal desalination, I will leave it for you to read through and make up your own mind. So Vayuja on the principle is very simple, right? Air contains water, very clear. Early morning dew, you can see your car gets frosted, whatever. So we know there is water. What if you pick up that water? That's it. That as simple as that. Now get into the flow diagram. The discipline, up to this it will look very interesting. Wow, this is a breakthrough here. Air is inexhaustible in the world, everywhere. Rajasthan, you will get air. What is the big deal? You can get water. Vayuja can come there. But question is, affordable, large, if you want to do, you have to develop a flow diagram. So let's take a flow diagram and develop. Should I do, or I will leave it to you to do that flow diagram? I won't do the calculation, but I will leave it for you to work it out, but it's like this. Basically what we should do, a flow diagram means, mind me, we have got the process. Air is drawn and that water has to come out of the air. How? 2-3 ways you can think of. If you had an adsorbent like silica gel is a standard, right? You have silica gel, pass wet air through that, water will get adsorbed onto the silica, dry air goes to the other end. This is fine. When water is stuck in silica gel, how do you get it out? You have to think. You have to think through fully, close the loop. Otherwise, the first one will look very nice, but when you draw, I will take an example. What this was done in Vayuja is, they said we will cool it because our air conditioners sometimes water is dripping on my head also. So if you chill it, water will come. So here is a process by which, here is a chiller. Atmospheric air comes. These are some heat transfer surfaces. Air goes out. Here when it comes, temperature, can somebody tell me what is atmospheric air temperature? Varies, but you can give a guess. 25. India, Vizag, India. You are not, Kashmir only is not India. 30 degrees. Compromise, 30 degrees. And from morning to evening, of course, it changes. So even if you take 130 degrees, what will be this air? How much moisture will be there?
1%.
Good question, right? You can, I mean, if you know, you will work it out. What you have to do, you have to take our hygroscopic charts, which will have relative humidity, etc. Or if you have a wet bulb and dry bulb hanging somewhere else, from these two you can find out and can calculate what will be the kilogram of air per kilogram of dry air. That is humidity, right? Kg of air per kg of dry air. 30 degrees, find it out, you will get a number. I am assuming that number is 2533132. The thing is, if the temperature becomes higher, you will probably get this number more, because things tend to evaporate more at higher temperature. If it is very cold air, this will be much less, and so on like that. Now you are going to cool it down. Idea being that when you cool down, the water will drop out. To what temperature do you have to cool it? When you have to develop flow diagram, all this we have to work it out. So anybody guess? Give a guess. Don't say we will cool it down to 50 degrees Celsius, then you will get 0. Any number less than 30. 10 degrees, likes to be a nice number, 10 degrees. Take it 10 degrees. So you are going to cool it down to 10 degrees. The assumption is when the air comes out from the cooling place, it has got down to cool down to 10 degrees centigrade. So this is 10 degrees. Now at 10 degrees also air will contain some water, right? It will not be zero. How to do? Again I have to go to the hygrometric charts and say at 10 degrees, this time it is, we will assume that it is saturated. I mean, we have cooled it down and water is come out, therefore it has reached saturation. Here it is not saturated. Here we are assuming, first assumption, reasonable assumption, because water is separated from there. More or less, if it is not saturated, this water content will be more in the air. Because it is saturated, means whatever it can lose, it has lost. So you will get saturated water content. For example, you work it out at 10 degrees. This is a very critical assumption of this. You may get something like 0.012. The virtue of doing this flow diagram and calculation is that otherwise what remains is a nice sounding concept, what I call as hype. First meets the, as they say, the tire meets the road. This is the time when your actual engineering will start kicking in. Every single decision that you make from here, you will go back and say, why did I do this? Because of this. And it's actually very. So if you do like that, from this we can make one conclusion. In this apparatus, water is dripping down. Liquid water is dripping down. Right? It was here. It got reduced to here. So the water has to go out from somewhere else. This water is what I am going to catch and then say it is Vayujal. Very simple. What is that? How much of water I want? From this, we have to know, start somewhere, Here is where we have to say, we are going to make it for a family. Who is the buyer of this? Not the citizens of the metropolitan of Chennai. Well, you can, but before doing that, let us first look at one family. One family, shall we say? For one family, we will try to get water. How much water per family? Come on, one of you. Six members. If you take 150, it becomes 900. Then we think, wait. By now you would have noticed, hey, this chilling, illing and all that is not going to be easy, simple joke. It's going to cost some money. But 900 and all that size of the equipment will become. Why 900? After all, this water is for drinking. Why you want to wash clothes with this? I mean, corporation gave you water, you can flush toilets also using that water. You want to flush toilets using this water or what? So now we will start saying that probably you will find out. Now go back and read all these YGL fellows who have come out with that. They come out with 140 to 200 liters per day. Is this. So if you take it as 140 liters per day, that's the water that should come out. Now the thing comes, per day is a funny thing, because 140 liters per day, if you put a clock, first hour will not be 140 divided by 24. Second hour will not be 140 divided by 24. Will it be? Why not? No, production. I'm not usage. I'm coming to the complication later on. First production. Production, will it be 140 divided by 24 in the first hour? What is first hour, you have to ask me. What is the sudden first hour? So let us say 6 o'clock in the morning is first hour. 6 to 7 is first hour. Okay. This continuously changes as the day progresses. So you have to know for the first time thing, from liters per day of 140 I want to convert it to some liter per hour and integrate it over that period of time. So that is the assumption we have to do and rework these numbers. 6 liters per hour. So start with 6 liters per hour. 6 liters per hour has to come. 6 kg per hour means how much of air has to be cooled? From here to here, 1 kg of air, if it goes, it gives 0.018 kg. And if you want 6 kg per hour, 6 divided by air has to flow through. Simple mass balance, which is 0.02, you take it as 200 kg, 2000 kg, how much is it coming? 2000 kg perhaps. No, much more than that. 0.1 itself will be 70. 0.01, huh? 700, 800 kg probably. So 300. So now, if you leave it, this is the scheme. So which means if this is the scheme that we have got is, you have to have, now line says air comes in. Yeah, how it will come, how it will go, there is a pressure drop in this. So it will not simply come and go. You need a flow device. So you have to put a fan. You will put a fan here or you will put a fan here. You have to take a decision. Each one of them has got an implication. To avoid too much complication, I will say I will put a fan here. And then you will have to have a filter. Quickly we will discover this air may contain some dust and all that should come. So there will be a dust, additional pressure drops. Now we will calculate one power using equipment has been identified. Its rating is approximately 300 kg per hour of dry air, and the pressure drop in which it has to work is pressure drop across this, and finally the air will have to go somewhere else. You will just leave it out. So you will estimate the one equipment required is this, second equipment required is this, third equipment required is this. Now with this, switch and find out investment cost. You will get some idea roughly, because you got at least 3 major equipments. You can find it out. And what will be the material of construction required? Fan will be a simple fan, right? It can be FRP, GRP, that kind of a fans. It's not high temperature, pressure, everything. Okay. Filter, easy, simple one. This heat exchanger, what kind of heat exchanger it will be there? It is complicated, because first of all it is air, so heat transfer coefficient will be low. Secondly, it is condensing type. If the droplets are immediately removed from that place, then the fresh surface is always exposed. So you have a fairly good heat transfer. But in this case, it is going to touch, form a film, and the film will roll down, and depending on your configuration. So there will be if you really go to the micro detail, if this is the tube, there is some tube in which we will come to the inside of the tube. Outside of the tube, air it goes, air hits it. This heat transfer coefficient experiment, you can do a guess by taking Perry or whatever it is, take a first cut, but experimentally you have to do that sort of thing. You will find that it is not going to be like steam heated boiling vapor, so it will be a fairly low number. So this heat exchanger will be a big heat exchanger. That is for one thing. And the material is, you want this visual to work for at least 5 years in a customer's premise, right? So you don't want to put it as cheapest steel material. At least you will go for stainless steel of some type. Even stainless steel corrodes these days in the air. So some stainless. So you can get that car. Story doesn't stop here. What is that is chilling it? We only consider the air part. We have not talked about what can chill air to a temperature of 10 degrees. Refrigeration system. So you should have another one, which is liquid refrigeration comes, evaporates, thereby picking up the heat. Vapors will have to go. There is a compressor. It will come. There is a condenser and return. Like our AC unit, one full-fledged things will come. And the type of the refrigerant you will choose, because you want temperature of 10 degrees. Additional capital cost, additional operating cost of that will come through. If you work it out and see for yourself what will be the investment cost per liter, then you can say MLD, million, first per liter. What is the operating for the liter? Then make your own judgment. Is it going back to affordable water for millions? Where you have got the numbers very clearly. Large, 12 rupees, 15 rupees, 80 rupees, 100 rupees, that's the range per 1000 liters. Other complication is this energy consumption will become very high. Please do work it out when you have time. It's a very, because you are allowing this cold air to simply go away. The next thing will come to chemical engineers is this air that is going at 10 degrees, why can't it cool the incoming air? Because this heat duty of this is, as it is written, will be for the water to be condensed, latent heat of condensation multiplied by that will be one big amount, plus the air has to cool down from 30 degrees to 10 degrees, and that is also a large quantity, right? So one clever idea will come, this air and incoming air, there is another heat exchanger through which it goes and through which it goes. So at least part of the energy of this you will pick it up. The negative that you will place is this fan, now pressure drop will increase of this fan, because it was just taking from one place to putting it. Now it is going through another heat exchanger. So then you will do a little bit of a compromise saying that, but that heat exchanger is not going to be high material of construction. After all, air to air. Okay, it will be big because air is on this side, air on that side also. But it can be made out of cheaper materials, whatever it is. Whereas I continuously save on operating cost of power. That energy is no longer getting wasted. So the team that worked on Vayugel, by the way, they worked out all this. Therefore, finally the device that is there is a well nicely integrated device, and the heat transfer coefficients have been substantially increased. All of you have seen the fins, and for extension surface, this you don't put a fin there, but you have a structured way of 3D printing of the tubes. So the tube itself is, so it breaks the film. So it's a technically a very very interesting, intelligent piece of design. So a very compact way of making it and connecting it and all that. The whole thing is beautifully packaged. You can go and install it, just only power electricity. And then you go through any of them. There are several manufacturers making it now. Take any one of them and look for that information of what is the cost of the 140 liters per unit. Cost meaning installed cost. Pay the money, they will give 140 liter equivalent. And how much of energy will be required to produce 1 liter of water. Do that, then go back to our first table, what will be the investment cost and what is the cost. Then you can make a judgment for yourself. Is that in all technology is for an application, that we have to always keep it in mind. So if we started the word by affordable for large mass of population, you make your own judgment. But if it is, forget affordable, innovative, nice area, you can have a different conclusion. So that brings me to the end of this project work, how to write for a given topic, whichever topic. Okay, so that is what it is. Now we have got another 1 minute or 2 minutes. What I can do is, next class, Wednesday we are trying to get an external speaker to come and talk. We are not sure because he has not confirmed yet. Otherwise, Professor Nagarajan may take, and I hope he gets well. As a further backup, in case he is also not well, and if you are not able to get, you have the misfortune of listening to me again on Wednesday evening. This time I will come out with technology development in green hydrogen, because that is a hot topic these days. So now that you have understood what I mean by technology development, you have to ask questions like, technology development for what market? Don't come back and tell me affordable green hydrogen. Yeah, you can have affordable green hydrogen also, but there will be a different technology. So you have to define your end market, what you are trying to do very clearly. Accordingly, I will give you some options of how it is being attempted and things like that. This is provided you have to have this misfortune only if the external speaker doesn't come and if Professor Nagarajan doesn't come. Otherwise, Wednesday we will meet. Last part for the day. By Wednesday, if I don't hear the group's project, it will be not good. You have to tell me. Please do that. Please do that on Wednesday. I really once again want to tell. Do not say we'll do it on Thursday. Do it on Wednesday. Because there is a big effort, and it is both for your learning. I am only going back to see passing, getting a grade, secondary. Keep it there. You know it much better than I do. So, but I want you to seriously take up the piece of paper on the first or second class what you wrote. What do you want to do with your life and your career? So with that, go back and write a time. There is a lot of work that you have to go through. But if you go do this work during this project, I can tell you it will benefit you enormously. Because this discipline, this is all the discipline is. Look at that, study existing completely, get a feel, look for opening spots with respect to market, come out with the creative ideas, do a check, again modify. This is it in technology development or manufacturing or EPCM, this is it everywhere. It's repeated in different units. With that, you will no longer be one of those where people say they are not industry ready. You will be ready for every industry. You may not need the detail on day one. Doesn't matter. If you go polymer plant, it will say, can I know what is polymer plant existing? It will take you a few months to get into what is existing. Some of you may get into fertilizer. For that, what is existing you will get to know. But the logic for anywhere is the same. So, do spend some time, decide on the topic, and one of you can, on behalf of the group, mark the rest of the group members. You need that. I will anyway that group I will put it into. I believe you are not able to see what are the rest of the. I am able to see every in my Moodle, but I think individually you are not able to see who are the group members, right? So I will this Excel sheet what I showed you, I will put it onto that, so you will know who your group members are. One of you, after talking, send it to me. Just inform the rest of the people so they are also aware of that. So that I didn't want to have everybody, how to write, all of you going back and saying it. That have quick talk between today, tomorrow, day after tomorrow, and send mail. So I will then write it down. That is it. The group one, I will add one more saying topic they have chosen is like. From there, I am at your service, answering your questions, providing support to you and things like that to make you think. Of course, I won't give you the direct answer. You don't want the direct answer from me either, anyway. But I will be like your mentor, going through. Can I do like this? Means, what do you think? Why should you do like that? I will direct you. I hope you enjoy that experience. For which only I need that on Wednesday, because I have to prepare 5 times, like you. So that is why I need that on Wednesday. Okay. See you guys.